What we see here is the main screen of Johnnny, which is a Neumann computer CPU, and we see if I compare to the textbook on page 41. So if you go to page 41 of your textbook, you see there all the different units which are also visible in Johnnny. Not as clearly. Some are really written out, and some are a little bit hidden. What we see here is memory. So that's that you could see as the memory. That's not cache memory. That's memory, RAM memory. We see here a control unit, which I clicked open. You can hide it or show the contents of the control unit. That's there. And we see here the ALU, the arithmetic logic unit over here, with the accumulator as the main part. So all those parts are there. We have a number of registers. Those are not very clearly depicted here, but this address bus is actually a register, and the data bus here part is also a register. We have one instruction register here and the program counter or PC sitting right here, and those are also registers. There's two buses. This is the address bus and the data bus, and it's actually the communication between the control unit and memory. And what is not really visible is the control bus, but that's actually all those buttons I can click here, which you did in the previous task. All those buttons, you can imagine those being connected to each other to one bus, and that will be the control bus. So the control bus operates, works on all those buttons and signals which button to press. That's the control bus. Now if I load a program, a very simple program that adds two numbers, you can see that it's loaded into memory. Memories have an address, memory cells have an address, and they all contain a high value and a low value. Actually, it's two different number values. What's important in memory, in this accumulator, the first part, the high part, is actually an instruction, and the low part is an operand. It works on the instruction. Instructions are numbered. We see here ASM. It says that because it's assembler. This is the assembler text. And if you would like to know what assembler is, then you go to your page of low-level languages, which is on page 49 of your textbooks. There you see mnemonic code. So the take, T-A-K-A-E, is a mnemonic code for reading something from memory. Now, all those behind every of these operators of these instructions, there's a number of buttons being clicked in the right order, and that's operated by this part here. It's default on fetch because that's the first step which is done to operate in a program. Is first fetch the instruction, like you see in page 43 of your textbook. Fetch the instruction and then decode the instruction, which will be done in here, an instruction register, and then execute the instruction. Then it will be executed, and in this case it will jump to a location in this microcode part, to a location which is the number of the instructions, like 0, 1, and with a 1 added. So if I go here to 10, we see here, now we see that's the take instruction, and that's actually all the steps that needs to be done to take a number and put it in the accumulator. What it also will do is jump with the instruction to the instruction point to the program count to the next step, and then then it starts again. A new instructions will be fetched, will be decoded, and then also executed. We can see this in very well detail if we open the control part and click on the microcode button over here. Not the run button, then it would just do the instruction. But if we want to see and witness the fetch execute cycle, then we have to use this button, one micro step. So if I click once, what you see is the program counter address, which is 0, which is moved to the address bus. the next step will be taking that number from RAM and put it in the databus. So the contents of address 00101 is put in the databus. You see the next button being pressed is the databus to the instruction register. So it will press that button, move the instruction to the instruction register. And now this is the same. And then the next step will be to execute the instruction. So we have fetched the command in the databus and decoded the instruction, which will happen now, and then it will be executed. So the decode step is nothing more than jumping in the microcode to the location where all the instructions and micro instructions are stored to operate this command here, take 101. The first thing it will do is clear the accumulator, put 0 in there, nothing happens there because there's already 0 in it. Then it does the operand here, the 010 here, operand, it will put in the address bus, and that will be used to read the content of that cell 10, which is somewhere down here, or should be somewhere down here. This 3 here will be read from memory with the next instruction, because it will pull from location 10 the contents of that cell and put it in the data bus. There it goes. That's 3 in there. Then it jumps to the next instruction. So the instruction is executed now. It takes the content of the cell with the address 10 to the data bus. It then adds that to the accumulator. Remember, the accumulator was 0, so adding or doing a plus there would move it to there. The other way would be to just move the data bus contents to the accumulator and press this button, but it chooses to do a plus. It adds 1 to the process counter, the program counter, sorry, and it's on 0. It's on 001 now, and it jumps back in the microcode. In this part here, jumps back to the fetch instruction. So the next cycle starts again. It's doing a new fetch, but now with a new program counter, 01, and then the whole stuff starts again. So I can click through that again. Goes to location 1. It pulls the next command on address 1. It pulls that to the databus, puts it in the instruction register and decodes it by jumping to the right location in the microcode, the add instruction, because the mnemonic, the instruction is an add instruction, which will add the contents of cell 11, of address cell 11, to the accumulator. You'll see later on. So it stores the 11 in the address bus, pulls from that location 11 the value, which is 4, stored in that location, was stored in that location, and then it adds the content to the accumulator, ends up being a 7 now. It jumps to the next instruction by increasing the program counter by 1, and then it jumps back to the fetch cycle by setting the microcode address to 0 again, and then the next instruction will be executed, which is a save instruction. Again, pulling the instruction, putting it in the instruction register, jump to the decoded by jumping to the marker code start, which is a save. It stores 12 in the database register, pulls that information. Now that's wrong. It pulls the accumulator in the database, and then the next step will be putting the database at the location where the address is, and by that storing it in memory at location 12. So what the program did is it pulled 3, added to the value in pulled 3 in the accumulator, added to that value 4, and then stored the result in 12. Now the program is done. It jumps to the next instruction. It starts a new fetch, which is a hold instruction which will effectively hold the program. First, of course, it has to decode the instruction, jumps there, and then it does a stop, sends a stop over the control bus, and then the program holds and the process is stopped. So again, we have our RAM here, our memory here. We have a register, two registers for address bus and data bus, a data register and an address register. We have here the accumulator in the ALU, arithmetic logic unit, and we have the two buses which are used to communicate with RAM. One address bus which sets the right address, and then a data bus which pulls or puts information inside memory. And then we have the decode cycle, which in this case jumps to the right to the proper location in the microcode. What we don't see is the control bus, and the control bus is nothing more as the connection between the microcode and all those buttons. You could imagine that there is wires getting out from here, which wires all the buttons that I can press in the whole control unit, and also in the ALU, and also in the memory section.